this video in 7.3, we're going to look at applying those sum and difference formulas that we've done from the last video. So here are 3 examples. We're looking to rewrite these functions using our angle theta or x, because that first one has x. I mean, you can change it to a theta. So if you want that to be theta, that's fine. So in terms of theta, so how does Cosette arrange the date? Well, she hangs out with her sister. Remember, they always comes first. And then she says their signs are different, and she puts Sinbad with his brother. Okay, so then we're just going to simplify this. Cosine of 30 is root 3 over 2. Cosine of theta we don't know, so we just leave this as cosine of theta, and then subtract sine of theta, which is 1/2, times sine of theta, which we don't know. So then we just have this. You can multiply, this is in the numerator, this is in the numerator, right? So we can multiply tops, we get root 3 cosine of theta minus sine of theta over 2. And then, oh, this is over 2 as well, because of 2 times 1 is 2. And so then we can do a common denominator here. Or we could just factor out 1/2, that would work too. Minus sine of theta. This whole thing's over 2, or times by 1/2. Okay, so now it's in terms of just theta alone, right? So now if you're given any theta, so any number, so like if you do cosine of say 102, and then you could rewrite that as 30, plus 72, and then you could just put 72 into this spot right here, and then you would have your formula there. Okay, so let's look at the second one. Okay, so here we're finding tangent of 45 plus theta, so we're just going to simplify this. So tangent formula is tan of the first, and then we keep the sign the same, so plus tan of the second angle over 1, then we switch our sign, so we'll subtract tan of the first times tan of the second. So tan of 45 is 1, so this is 1 plus tan of theta over 1 minus 1 times tan of theta. So this is 1 plus tan of theta over 1 minus tan of theta. So then we can go ahead and rationalize. Oops, 1 plus tan of theta on top and bottom. So this is 1 plus 2 tan theta plus tan squared of theta all over 1 minus tan squared of theta, which is the same as negative secant. Not quite negative secant, right? So I'm not sure if that's, how far they want you to go. No, it's not. This is how far they want you to go, right there. So that's it. So then we can plug those. Once we know what theta is, we can plug those into our formula and solve. So one step a little further, not needed. So now we have sine of 180 minus theta. So here, Sinbad arranged the date. He takes him, and he goes with Cosette. And then he thinks their signs are the same. And then he takes his brother and then puts her with Cosette's sister. So sine of 180 is 0. And cosine of 180 is negative 1. So this becomes 0 plus sine of theta is sine of theta. So sine of 180 minus theta is the same as sine of theta. Okay, so here's another one. We're looking at 2 different angles. And these angles in standard position, remember standard position is just opening up with the one ray on the x-axis and the other one open up counterclockwise to some point. So we have 2 angles. In standard position, we have sine of A, so we have one angle, A, and it's going to open up to where we have our y value of, or where our sine of A is 4/5. and pi over 2. Our angle is somewhere between pi over 2, which is 90, and pi. So actually we're opening up, A is somewhere in this second quadrant. Okay, so A is somewhere over here. Somewhere landing over here. And then cosine of B, so you notice that they have two different angles, A and B. Okay, so A and B. And B is negative 5/13. Okay, and this angle B is in pi, between pi and 3/2 pi. Okay, and we want to find sine of A plus B. So angle B is somewhere down here. Let me switch colors. B is somewhere down here, right? So it's opening up down here, right here. And we want to find, okay, what is angle A plus angle B? So sine of A plus B, Sinbad's arranging the dates, so he takes himself, hangs out with Cosette, and he thinks their signs are the same, and then he makes his brother hang out with her sister. Okay, so we need to find, in order to find sine of A plus B, we need to find sine of A, cosine of B, which is given, right? Sine of A is 4/5, and cosine of B is negative 5/13. So we can multiply these, but we need to find what sine of B is. So we have sine of A, but not sine of B. We have cosine of B, but not cosine of A, so we have to find out what those are. Well, here we're going to use Pythagorean identities. Sine of A, sine squared of A, plus cosine squared of A equals 1. And we know what sine is. Sine is 4/5. So if we square that, and then we subtract that from 1, we will get, so then if we minus that, so cosine squared of A is equal to 1 minus 16 over 25, so that's 25 over 25 minus 16 over 25, which is 9 over 25. That is cosine squared of A, but we just want cosine of A, so cosine of A is equal to the square root of 9 over the square root of 25, so that is plus or minus 3/5, but we can go back and we know where A is, right? A is between pi halves and pi, so that's the second quadrant, and cosine is negative. So actually we know this answer is actually going to be negative 3/5. So now we can come back to our formula, and we have negative 3/5 for cosine of A. So cosine of A is negative 3/5. Now we just need to find sine of B, and we can do the same kind of method. We can take sine of B, sine squared of B plus cosine squared of B equals 1. And so that means that sine of B will equal the square root, plus or minus, of 1 minus cosine squared of B. So what's cosine of B? Cosine of B is negative 5/13. So negative 5/13. We're going to square that, and then we're going to take 1 minus that, and then we're going to square root it. And sine of B, B is in the third quadrant because we're between pi and 3/2 pi. So our answer is actually going to be negative. So then we get 25 over 169. We can take 1 minus that, so that's 169 over 169 minus 25 over 169. And we'll square root it, and we know our answer is going to be negative. So sine of B is going to be negative square root of 145? 144 over 169, and square root of 169 is 12 over 13, so negative 12 over 13. So we can come back, negative 12 over 13, negative 12 over 13. Now we can multiply these, we can add the two and then get our answer of sine of a plus b. So let's go ahead and delete this. Scroll down a little bit, maybe delete some more. Okay, so that'd be negative 20 over 5 times 13. 60, 65. And this would be still, oh, that's nice, 65 and 65, so that means we have a common denominator, right? So sine of a plus b is equal to, and we have the signs of negative 20 and a positive 36. So that is 16. So we have sine of a plus b as 16 over 65. So there's our answer. So that's how you can apply it there. So we can also find tangent of a plus b. And tan of a plus b is tan of a plus tan of b over 1 minus, change the sign, tan of a times tan of b. Well, tan of a would equal sine of a over sine of b, and tan of b would equal tan sine of b, sorry, sine of b over, oh, what? Sorry, I'm a little distracted. Cosine here. Cosine of b, and this would be cosine of b. This would be of a as well. So I just realized I might have messed up on the last one. Like, not the problem-wise, but pushing record. So I don't know. I'll wait till the video's done. So I might have missed the last example. Not I got the last example wrong and just missed to do it. So sine of a, from the last example that you might have missed, because I might have not pushed record, but oh well. Here it is. So sine of a is 4/5, and cosine of a is negative 3/5. So 4/5, 4/5, negative 3/5. Flip that, the 5s are going to cancel out. We get 4 over negative 3. 5, it will be times by this. So the 5s will cancel out. And I'll get negative 4/3. Okay, sine of b, from the last example, negative 12/13, negative 12/13, and negative 5/13. Negative 5/13. So negative 12/13 over negative 5/13. Flip, 13s are going to cancel out. You get 12 over 5. So it's 12 over 5. Okay, so then we can use our formula now. So tan of a plus b is tan of a, which is negative 4/3, plus tan of b, which is 12/5. Ooh, we're going to have to find a common denominator there. And then over 1 minus tan of a, which is negative 4/3, times 12/5. Okay. So common denominator would be 15, so 5 and 5, 3 and 3, so we get 36 over 15 plus a negative 20 over 15 is 16 over 15. And the denominator, oops, I need to kind of see that. It's 1 minus a negative 48 over 15. So this would turn into 15 over 15. Subtract those, that would be, we'll add those because the negative and negative make a positive. So we're actually going to get a positive 53/63 over 15. Then that flips, so it becomes 16 over 15 times, instead of divided by 60, instead of divided by 63 over 15, it's going to be times by 15 over 63. And so these will cancel out. And then we get our 16 over 63. So tan of a plus b, tan of a plus b is equal to 16 over 63. And then since this is positive, that means we're either in the first quadrant or in the third quadrant. But on our previous example, tan or sine of a plus b was 16 over 65, so that's also positive. So then tan of a plus b, or actually a plus b, is in the first quadrant. So it's in the first quadrant. Okay. So here on page 655, maybe 56, go ahead and do numbers 71, 75, 79, and 91. And those are just the applications of the sum and difference formulas. In the next video, we will do verifying using the sum and difference formulas. So here is number 71. So here's cosine of 60 plus theta, so writing in terms of theta. So Cosette arranged the date, her and her sister hang out. She thinks their signs are different, so and then she puts Sinbad with his brother, so I need another sign here. And then cosine of 60 is 1/2, and that means sine of 60 is √3/2. Bring down the cosine of theta, because we don't know that. Bring down the negative there, subtraction. We can write this, basically we could factor out a 1/2 if you want to, because they both have 1/2 in it, divided by 2. Cosine of theta minus sine of theta. And so there would be our, of √3 sine minus √3 sine, because that √3 is in the numerator. So something like that. You could leave it just like this is fine too. You could write it as cosine of theta over 2 minus √3 sine of theta all over 2. You could do that. You could use it as a common denominator. Bring those two together, so you could leave it like that. Any of those answers will do. Alright, so here's tangent. So tangent of theta, keep the sign the same on top. Change the sign on bottom. And also multiply on bottom instead of adding or subtracting the two tan thetas, or tan of the angles. Okay, so tan of 30 is, since it's 30, that's a pi over 6, so that's √3/3. So tan of theta plus √3/3, and 1 minus tan of theta times √3/3. So I'm pretty sure they probably want us to simplify a little bit. Tan of theta plus 3/3. I'm just kind of, and when I'm multiplying tan of theta, so I'm going to get √3/3 tan of theta. So I can put that tan of theta on top there on the bottom. So I have a few fractions that I could simplify. So this would be 3 tan of theta over 3 plus √3/3 in the numerator, and then the denominator would be 3/3 minus √3 tan theta over 3. And we can simplify, bring those together now under one common denominator. So there's my bottom, all over 3. And then my top would be 3 tan theta plus √3 all over 3. Oops. Sorry about that. Getting a little crowded down there. So here it is. I'll rewrite it real quick. Divided by, so notice these are both over 3, so I could flip the bottom one and multiply. That would basically just cancel out these divided by 3's. So then we get, as a simplified answer, I'd get 3 tan theta plus √3 over 3 minus √3 tan of theta. So in the back of the book, it'll look like this. √3 tan of theta plus 1 over √3 minus, oh, that should be a √3 minus tan of theta. So here what they did is basically just factored out a √3 into this, or actually distributed. Basically, if you take this bottom one and distribute a root 3 here, root 3 here, root 3 here, root 3 here, you get our answer, right? So this will turn to 3 like we have, this will turn to 3 like we have, this would turn to square root 3 like we have, and this would turn to root 3 tan of tangent. So it's the same answer as the back of the book. Okay, so number 79, we have sine of 270 degrees minus theta. Well, Sinbad arranged the day t goes with coset. It says their signs are the same, and he takes his brother, puts him with her sister. So we can simplify sine of 270, that's 3 halves pi, and 3 halves pi is sine is negative 1, so that's negative 1. Cosine is 0, so 0 times sine of theta equals 0. So this whole right term over here is 0. So we just have negative 1 times cosine of theta, which is negative cosine of theta. And then minus 0 would still be subtracting 0, so we just have this answer. Okay, last one. Okay, so we're given that we have cosine of s is 3/5 and sine of t is 5/13. And we want to find sine of s plus t, and then find tangent of s plus t, and then find out what quadrant s plus t is in. Okay, so sine of s plus t, that means we need sine of s, cosine of t, signs are the same, right? And then sine of t, and cosine of s. So we have cosine of s and sine of t, so we have this one. Now we need to find the other one, right? And that's where we use Pythagorean Theorem. So hopefully I recorded my example of this one. If not, at least you'll see it here. All right, so we have sine squared t plus cosine squared t will equal 1. So that means cosine t will equal the square root of plus or minus, and then we look what quadrant we're in the first, so actually these are both going to be positive. But then we just have to figure out what s plus t, what quadrant that is in. So all our answers so far will be positive because we're in the first quadrant. S and t are. Is 1 minus sine squared of t. So we have squares 5/13. We're going to square that, and we get 25/69. And we're going to take 1 minus that. So that'd be taking 69 over 69, or 169, sorry, 169 over 169 minus 25, which we found from our previous answer, our previous example, which is 144. 169, we're going to square root that, so cosine of t is equal to 12 over 13. So now we have cosine of t, so 12 over 13. A lot of these answers will be the same because we're square rooting, so we have just the, perfect squares of, 9, 25, 36, 144, 169, and those ones, right? 225, certain ones like that. So a lot of these answers have the kind of same numbers in it because we're looking for basically perfect squares, so we have this square root symbol. Okay, and then we can do the same steps with, we're finding sine of s is equal to square root of 1 minus cosine squared of s. And cosine squared of s is 3/5. We're going to take 3/5, and we're going to square it, so we get 9/25, and then we're going to take 1 and subtract that from that, so that's 25 over 25. And so we get 16, so perfect square, yeah, as you can see. All right, and then we'll square root it. We know the sign's going to be positive because angle s is in the first quadrant, so we get 4/5. So sine of s is 4/5. 4/5. Now we can multiply these ones, and then add them together. So we get, what did I say 5 times 13 was? 65. Right, so this is 48. Maybe I should use a different color. 48, I guess I can write down here. 48 over 65. And this is going to be 15 over 65. We can add those, and we get 63 over 65. So 63 over 65. So that is sine of s plus t. Now we want to find, so sine of s equals 4/5, right? Let me go back. 4/5. 4/5 and 3/5. 4/5, 3/5, and then t is 12/3, 5/3, 12/13, 5/13. So this was cosine of t, and this is sine of t. This is of s. Okay, and then we're looking for tangent. So tangent is just sine over cosine, so tangent of s plus t is just going to be sine. Well, you could do it this way, sine of s plus t. And cosine of s plus t. So you could do it this way, or we could use the... So this is one way that you could do it. And then another way is to find out what... Or is to use the formula, which is probably the way that they want you to do it. So that'd be tangent of s plus the tangent of t over 1 minus tan s times tan of t. So that's the proper way, but you could do it this way, and we could figure that out. Because all we know from the previous answer that sine of s plus t is 63. Did I say 63 65ths? So cosine of s plus t would be cosine of s times cosine of t, which we do have those answers. And then difference, right? Or it is the sum, but we switch the sign. And then sine of s times sine of t, which we know the answers to these. So maybe I'll just do it this way just for something different. Because I actually recorded the example of the tangent one. So let's do something different here. So 4/5, 3/5, and then 12/13, 12/13, 5/13, 12/13, 5/13. Make sure of that real quick. 5/13, 5/13, 12/13, 4, 3, 4, 3, 4, 3. Oh, so I kind of messed up, right? Because sine of s is actually 4. I did sine it, yep. Okay. So we are good. Okay, so we can multiply those, multiply these, and then subtract. Alright. So here we go, 36 65ths minus 20 65ths is 16 65ths. So then tangent cosine of s plus t is 16 65ths. And then we're finding tangent, which we won't use the formula this time. Do something a little different because there's a lot of different ways to go about this. So that'd be sine of s plus t over cosine of st. So that's 63 over 65. And then times by, if I flip that, it would be 65 over 16. So we get 63 over 16. So there's our answer for tan of s plus t. So this is positive. And our answer for the last one, I believe, was positive. So that means we're still in the first quadrant. Okay, so those are all the answers for this section, or for this part of this section, I guess.